photoelectric effect. What is this one? Suppose a photon is falling on a metal, and you know this metal contains some electrons, and a light is falling on this metal. So what will happen? What is happening is the electron will be ejected from the metal. But so for that process to occur, you can see the inner electron should come to the surface. This is the first step. So when it is reaches at the surface, the energy, that is kinetic energy of the electron, is equal to 0. And you know some energy is required to come to the surface of the metal. That energy is called threshold energy, that is phi. So this is threshold energy. That is the energy required to take the electron to the, so that energy is taken from the energy in the photon, that is E equal to h nu. So some part of this energy is used by this electron to reach to the surface, and the remaining energy in E equal to h nu will be converted to the kinetic energy of the electron, and these electrons are called photoelectrons. So what will be the kinetic energy of this electron? You see, the total energy is h nu, and some energy, that is phi, the threshold energy, is used by the electron to reach to the surface of the metal. So this minus phi. So that will be the kinetic energy of this photoelectron. This is a very important relation. And I can find out the momentum of this electron also. How? We know the kinetic energy is p square by 2m, that is equal to h nu minus phi. So I can rearrange this equation. So I get p equal to root 2m h nu minus phi. This is our photoelectric effect. So this equation is very important. Compton effect. What is Compton effect? It is an inelastic scattering effect of a photon by an electron. This is what Compton effect. It is a inelastic scattering. Suppose we have electron here, and a photon is incident on this electron. What will happen? So some of the energy in the photon, that is E equal to h nu, will be imparted to the electron. So what will happen? The electron will ejected in this way. And I told you this is an inelastic scattering. So the remaining energy in the photon will be like this. So here you can see the wavelength is increased. See, that is this energy is E prime, that is h nu prime. So when we are comparing the frequency of scattered photon and incident photon, the wavelength is different. For the scattered photon, the wavelength is increased, right? Because some of the energy is imparted to the electron. And we call this electron as scattered electron. And if we consider this is the x-axis, then this angle of scattered photon is phi and angle of scattered electron is theta. And for this photon, incident photon, it will have some momentum, that is E by c, that is h nu by c. So this is the momentum of the incident photon, and similarly we can find out momentum for scattered photon, that is p prime, and we can find out the momentum of electron. Here it is 0 and here it is p. And here I tell you one more point. See, here momentum of photon is not equal to 0. That is equal to h nu by c. That is, we know P is equal to mv. So it is here, it is h nu by c. And you know one more thing, the rest mass of photon is 0. But when it is in a motion, it will have certain mass. The mass of photon in motion is not 0, but rest mass of photon is 0. And from this graph, by considering the momentum conservation, we can derive the following. I am not doing the derivation because it is not required for you. You just remember the equation, final equation. Okay. So finally, we get the Compton shift. That is, I told you, the wavelength of scattered photon is greater than incident photon. So the shift in wavelength is delta lambda, and that will be equal to h by m0 c into 1 minus cos phi. And here the value of h by m0 c is 2.46 into 10 raised to minus 12 meter. This is a very important equation. And I tell you one special condition, that is when phi equal to 90 degrees, then you can see this delta lambda is equal to h by m0 c.